This is the boiler room at the Mazur Park Apartments in Lowell, Massachusetts. Installed here are 2 KBN 400 boilers, 2 Armor 286 water heaters. Went in to replace a bank of hydrotherms that provided heat and domestic hot water through the same system using a copper heat exchanger under the back. The system had to maintain temperature of 180 degrees year-round just to provide that instantaneous heat. The heat distribution is Whalen air units, so we'll be lowering the water temperatures in the wintertime to between 90 to 120 degrees based on outdoor temperature, and then using the separate system to provide domestic hot water. By doing that, the Armor water heaters run at an efficiency around 97% year-round because they're seeing that incoming cold water, their water temperatures don't exceed the condensing point. The boilers are allowed to keep condensing all the time because we keep those water temperatures down. We will see return water temperatures to the boilers, probably at the highest of about 110 to maybe 115 degrees. Each boiler is equipped with a Bell & Gossett EcoCirc XL 3645 variable speed pump. The boiler will be controlling the pump via a 0 to 10 volt signal to ramp the pump up and down with the firing of the boiler, monitoring the delta T. So as the boiler tries to maintain that 20 degree delta T at all times, it slows the flow down across it as the firing rate decreases. So let's take a look at how all that is actually working. So as you can see, the pump is installed here on the return inlet to the lock and bar boiler. What we're going to do now is power up the system. In this application, we're powering the boiler pump constantly, providing an external start-stop from the boiler and then a 0 to 10 volt signal from the boiler as well. Now we power up the system. Basically, the first thing the pump does is goes through letting us know what it is. It's a single boiler pump. Here's where we would do some connectivity, and then letting us know that it doesn't have a start-stop signal right now. So it's basically in stop mode. Now, once the pump is given a start-stop and then sees a 0 to 10 volt signal, it'll automatically respond to those. So we're going to go ahead, turn the boiler pump on, give it its initial enable. What you're seeing here is the degassing cycle. Now the degassing cycle is something that the boiler pump will only do once on its initial startup. And what that really is kind of a de-aeration, and it's going to almost pulse the pump to get any air out of the system. That only happens once and can actually be deactivated if you wanted to. If you wanted to deactivate the degassing cycle, it's really you're holding these 2 buttons for 10 seconds and the degassing cycle will never repeat itself. Flashing indicator down here lets us know that the pump is receiving that 0 to 10 volt signal right now and is going to respond to it once it completes this degassing cycle. So to disable the degassing cycle, you would hold both of these buttons. We get out of it. Now we're looking at the pump receiving a signal to run at its maximum RPM of 3,750. Boiler is going to be at full fire. Be looking to maintain that delta T. We can switch through. So we can take and look at the watts. Currently consumed by the pump right now is 200. Generating about 6.8 meters of head pressure right now. I'm sorry, it's 4.65 meters of head pressure right now, or 14.45 feet as we switch into the English version. RPM's back at 3550, 195 watts now. And let's switch over and see what we actually have. We're moving 30 gallons per minute. So I'm going to just go over and take a look and see what the boiler's doing right now. So the boiler's running a very low delta T right now. It's running at about a 3 degree delta T, just into startup, and we've actually brought it to about 20% right now. So it's actually beginning to lower the output rate to the pump. We should begin to see our speed dropping. right now you see the output percentage decreasing to the pump as the boiler is basically looking to increase its delta T. Right now maintaining just a 5-degree delta T, and it's just taking its time to kind of balance out where it wants its pump to operate. So right now we're sending a 6-volt signal out to the pump. Basically our percentage does correlate directly to voltage. We'll kind of move back around to the pump. You see that the speed of that pump is continuing to drop. And we're now drawing 100 watts as opposed to the initial 200 watts and continuing to drop. So at 75 watts, we're the equivalent of basically your typical little small cartridge circulator, is what this pump is drawing. And let's go back around and take a look at the delta T. Delta T right now is at 8 degrees at the boiler's 20% firing rate. So it's a substantial improvement over what we would normally see. And there we are right now, almost down to the minimum output that we would send this pump. In this case, 25% is where the minimum output, or 2.5 volts of the and with a delta T of 10 degrees this moment in time. The driving factor of the boiler is trying to get to that 20-degree delta T. Now let's go back and see where our pump is at its minimum speed here. So, giving the minimum speed now to the pump, or what the boiler will drop down to. The boiler drops down to 2.5 volts. We're basically drawing 35 watts at this moment in time, as opposed to when this pump is at full fired and it runs at 200 watts. It's a fairly substantial savings there. But let's take a look at what else we see from the pump right now. Moving 16 gallons a minute, 3 3/4 feet ahead, and 1800 RPM. So we've definitely slowed down. We're going to get a little better cycling of our boiler by not rat racing as much through there as we normally would, and definitely a substantial reduction in our energy consumption by reducing that now to 35 watts. The connections to the pump are actually fairly simple. Kind of beneath this cover here. So basically have our line voltage input here. Our black and our white are our 0 to 10 volt signal from our boiler, and the green and the white here is our start stop from the boiler. So it's a dry set of contacts on the boiler, because at the board here we have actually 5.5 volts generated all the time to use for that start stop. Now let's do a kind of a quick little experiment. Let's take the 0 to 10 volt signal away from the pump, which is going to cause this thing to ramp up and go to its full fire or full speed. So I've removed the 0 to 10 volt signal, and the pump has ramped right back up to its full speed. Big question is, how does this now affect delta T at the boiler? So as you can see, delta T at the boiler has now gone from 10 degrees down to 5 degrees.